Hi, I'm Jake, product manager at OpenDrives, and I'm here to give you an overview and demonstration of our latest product, Edge, which provides local speed access to centrally held data. By the time we're done, you should have a good idea of Edge's features and how and when to use them. Let's get into it. So first, let's start with the problem we're working to solve, which is you pay for centralized data twice. No matter who we talk with today, our customers universally describe pain that's experienced through high egress costs from their cloud environments, latency from working in cloud and hybrid environments, and difficulty in managing the distribution of their data to their users. In the case of media and entertainment, this can look like bespoke copies of daily footage being transferred to individual client workstations, each transfer racking up egress costs, and editors having to deal with workflow restrictive latency. With Edge, that same data set can be transferred to a single storage location on site where multiple editors can access directly at once, preventing multiple egress charges and offering local speed performance. But how does Edge actually facilitate that? Well, let's take a look at the two operating modes for Edge and the different use cases they can cover. Currently, Edge supports two ways of moving your data between your Cloud Hub and your Edge storage location: transfer jobs and transparent cache. The easiest and most simple way to look at this is if you can write down what needs to move and when, use a transfer job. Transfer jobs let you target the specific dataset you want to pull down from the hub and configure parameters for how and when that data moves to the edge. You can set schedules to ensure the data is moved both in a time when you have low traffic, say overnight, and you can determine the shape of the transfer, whether it copies, moves and deletes, or makes identical mirror versions. If, say, on Tuesday, your editors will be working on the daily footage that was shot and uploaded to the cloud on Monday, you can set your transfer schedule to target the dailies folder on the hub to transfer overnight on Monday, ensuring that the data is ready to go at the edge location by the time your editors roll in for work on Tuesday morning. You can even leverage transfer jobs to coordinate multiple sites for a true 24-hour production workflow. Say your studio in Los Angeles completes its work and pushes their assets up to the hub in time for the London studio to pull their latest down and begin their own work on the assets when they roll in for work in the morning. Transfer jobs are really great for predictable workflows when you know when and where your data needs to be. But what if your workflow is unpredictable and you don't know exactly which data your users will need and when? This is where the transparent cache comes in. Transparent cache provides your users with a view of the Cloud Hub's data as though it were a drive mounted on their workstation. The data still stays stored at the hub until a user begins trying to access it. Once the user begins accessing a given file, initial access is served at WAN speed over the network, while in the background, Edge will start pulling that file down from the hub so it can be accessed and served with the underlying storage appliance's performance guarantees, or in our case, OpenDrives Atlas. Transparent cache still does offer you some level of predictability in your data movement, though. Consider when you might have shifting daily working sets inside a large project. This goes beyond the scheduled transfer jobs use case that we've looked at on the left. In this scenario, you would set up your transparent cache such that the cache warming schedule stages the predictable core data set you absolutely know will get worked on. So for instance, tonight, have the warming schedule prefetch the shots that you know will be edited tomorrow. But any other data around that known predictable core data set that the warming schedule didn't cover can be fetched on demand through the transparent cache, covering both the known and the unknown parts of the workday and only pulling down data that was accessed. Or you might think about another scenario where you need ad hoc pulls from a mastering or deliverables archive, redelivery, versioning, or fixing one asset without restoring the entire archive to the edge first. The transparent cache will let you pull an individual file down on demand. You can work with it and then ensure your changes are reflected back up to the hub. So again, if you don't know exactly which data your users will need and when, transparent cache is the way to go. But Let's take a closer look at both, and we'll focus first on transfer jobs. With transfer jobs, an admin defines the targeted dataset, when it moves, and how. We support several different backends, including S3, Azure Blob, Google Cloud Storage, Google Drive, and of course your local NAS. Edge also supports 4 different movement types. For transfer jobs, we're just going to focus on the first 3 in blue. The copy movement is a simple duplication to the destination from source. The move operation will transfer files to the destination and then delete them at the source, freeing up space. And the mirror operation makes the destination match the source identically. To contextualize these in a workflow, you might consider something like a scheduled copy job to the cloud as a backup workflow, and how often you have it scheduled to run is your recovery point. Or, for instance, a move job to a less expensive storage tier in the cloud could serve as an archive workflow. You clear up space on your primary storage at the edge, and your finished work is sent to its forever home. But what does that all look like in action? Let's get into an actual demo and put our hands on the data ourselves working with transfer jobs. Follow me into this demo. Let's go into a live demonstration of using Edge with transfer jobs. Now, in the background, I've already configured a few things that are foundational to operating Edge. On my host NAS for the Edge location, in our case that's Atlas, I've already set up a pool and a file system that can serve as our data store for the Edge instance that the Edge will connect to. Take a quick look here. I'll show you where I've set that up. Got my demo location configured, and I'll just highlight very quickly the mount point because this is key information to deliver to Edge on how to establish its connection to this file system. Really quickly, I'll use Atlas's Explore feature to check out the contents of this file system, and we can see here, it's empty right now. Nothing has landed here at this data store location just yet. Additionally, I've also set up a MinIO instance to simulate an S3 object store as a Cloud Hub. So this is the other side of our data lifecycle workflow. In an example environment, you could imagine that this Cloud Hub is the landing repo for all fresh data and is intended to operate as the single source of truth in the storage environment. In a media workflow, for instance, this is where all your dailies would land. Editors would check out that footage to work on at their local Edge location, and then they can push those changes back up to the hub in a content sync lifecycle. And just to give you a quick glance, we'll explore the bucket here, and you can see some demo data that I've put in here. It's mostly a mixture of video files and PDFs, but that's going to serve as our Cloud Hub, which will be our single source of truth repository. Let's go over into the Edge UI and start establishing connections to those data stores, both the data store in Atlas Core for our Edge location and the MinIO S3 bucket for our Cloud Hub location. So first up, you can see here in Edge, we've got a pretty simple UI and really 2 tabs you switch between your data stores and your transfer jobs. Here we've started on the data store UI page, and you can see we've got some data stores that we've already set up, but today we are going to set up the data store connection to that file system in Atlas Core. So let's click the Create button and give it a name. Call it Jake Edgebox. Give it the designation for the local side. This is intended to be an Edge, and we'll take that mount point in Atlas. Take this, copy it, and we'll add it in here. Additionally, just for ease, you can take that mount point or you can browse. And we can go ahead and head straight there anyhow. And the same thing happens there. Let's configure the data store and establish the connection. And voila, you can see it here. You can see in the UI that we do report on capacity currently. Obviously there's 0 because we haven't transferred any data down to our Edge location just yet. But the next step before we do anything else will be to set up our connection to the MinIO S3 object store. So let's set that up. Give it a name first. type is already set to S3 for us. Let's designate it as our hub. Let's grab our endpoint real quick. One moment. And the bucket name, which our bucket name is Edge Demo Bucket. Grab my access key here from off screen and my secret. And let's configure the data store. And voila, the connection to our S3 bucket is established. So now you can see they've both shown up here in the list, and we can click into either of them to view basic details about it. If you need to, you can click the edit button to change out the name if there's a misspelling or you need to update it, as well as update the credentials if you needed to rotate those out. Additionally, you can see any transfer jobs that may be associated with this data store. We haven't set any of those up yet, but we will do that next. So let's go over into transfer jobs with just keep in mind that these are our two data stores, our Cloud Hub and our Edge box, and we are going to be transferring data between the two. Let's go to transfer jobs. So coming into the transfer jobs UI, you can see that we already have a few set up that we've been playing with, but today we are going to set up a new job to work between the two data stores we just created. Clicking on this plus icon in the top right corner brings us to the job creation flow. You'll notice that we do support 4 different movement types right now: copy, move, mirror, and transparent cache. For right now, we are just going to focus on copy, move, and mirror, and we'll come back to transparent cache in a later demo. But just a quick note on these 3 jobs we are going to focus on, just to describe them in a little bit more detail than the help text provides. Copy you want to think about as a transfer job type that duplicates files from the source data store to the destination, adding new files and updating changed ones while never deleting anything at the destination. You'd want to choose this when accumulation is safe or desirable, such as pushing finished work up to the hub without risking files that other sites have added, since it's the non-destructive default movement type. Whereas with move, for example, move transfers files to the destination and then removes them from the source once the transfer has succeeded. So data ends up living only in exactly one place. You'd want to choose the move type, for instance, when the source is meant to be temporary, like clearing an onset node after ingest and relocating finished projects off of primary storage to reclaim space. And lastly, mirror makes the destination match the source exactly, which means it also deletes files at the destination that no longer exist at the source. You'd want to choose mirror when you want a location to be a clean reflection of an authoritative source, such as distributing a curated reference library where retired assets should disappear rather than linger. But today, I'm just going to go ahead and set up a simple move job, and this will transfer the data down from the hub to my edge location. I'll select the source data store and destination data store that we set up. So source is going to be our Cloud Hub admin.io bucket, and destination is going to be our local file system here on the Edge box. You can also see here that we have conflict policies. Conflict policies are a safeguard on how to handle your data transfer in the event that more than one edge location has written to the same path. Instead of immediately overriding and clobbering someone's progress, Edge offers the admin an opportunity to either intervene and reconcile, or push the transfer through, but keep backup copies for a later reconciliation. For this transfer job, I'm just going to select the backup option that's already defaulted there. Let's also just do a quick exploration on our advanced options. In this menu, you can configure a schedule for the transfer job operating on a daily, weekly, or month or hourly schedule. I'm going to leave the scheduling off for this transfer job, but just know that it's there. You can also have options on how the backup directory, in the case that you've chosen the backup conflict policy, how the backup directory is handled. I'm going to leave these defaults in place for this job for right now, but moving on further down, you've got a retry policy that you can set in case something hiccups in the transfer job process, like losing the network connection or access to the hub. And last but not least, you can leverage our filter tool to hone in on specific types of data you may want transferred. If you only want to target video files, for example, you can select the filter preset for video files or manually add the extensions that you know you need to care about here. We also have options on filtering by modification time or by minimum size or maximum size. I'm going to leave these blank for this job and just target moving the entire data set from my hub down to the edge. Minimize this menu here. And one last thing I forgot to do here at the beginning was give this job a name, so let's go ahead and name it. Hub to edge move, pretty straightforward. Let's create the job. You'll notice here, because I have done the move operation type, it wants to just make sure that I confirm and understand that this does transfer files and deletes them from the source. Just double checking that you're clear on that. I understand, create the job. And there it is. You can see it shows up in our job menu. It's never run yet, but we do have it here waiting for us to push the play button. Like I said, we didn't create a schedule with this one, so it's only going to run when we manually push it off. One last quick check. We've got our data here sitting in our demo bucket. We don't have any data that we can explore here yet in our file system on the edge location, but let's see what happens when we kick this job off. I'll press the play button, and you can see that it scans for a moment, and it'll report some brief progress before this transfers very quickly. But proof's in the pudding, so let's go double check our data stores and see that indeed the data moved out of our S3 bucket and into our file system locally here on the edge. So let's go to our file system, and I'll just hit a refresh on the page. And let's dig in, and here we go. These were, let me expand the rows. These were all 16 files that we had up in our bucket on MinIO, and they've now transferred down to our location on Edge. And this is the location that your users' shares would connect to and they would operate out of. Let's go double check over here in our bucket. I'll do a page refresh here. And voila, we've got our backup directory, but otherwise the files have moved out. And there you have it. We've now successfully transferred our data out of MinIO and down to our Edge location, and it's available for our users to start working with. Now, if I wanted to, I could set up a second transfer job, and I'll go ahead and demonstrate that really quick. We'll call it Edge to Hub move, and we'll swap our data stores here. We'll make the source data store our local edge box, and you can see here it's throwing me an error saying you can't have two locals at once. Let's set this up for our S3, and we're going to push back from our edge to our hub. I'm going to leave the conflict policy at the default. I'm going to leave our advanced options at the default, and I'm going to create the job. We can see here now that Edge to Hub move is available for us to operate and run. We can see it's never been run. And just a quick note to take a look into the details page on our first transfer job. You can now see that there's run history from that first job that we just played a few minutes ago, as well as some basic details around the nature of this transfer job. This is where you'd come if you wanted to audit any of your previous runs in the transfer job, ensure that data moved the way that you expected it to, when you expected it to, and if any errors occurred during that transfer job, those errors would be flagged here as well. But let's go ahead and kick off our move back from the ZFS file system on our Atlas box at the edge up to our hub. We'll start that job. You can see here in the table that we provide information on your source and destination and the nature of it, if it's a pull or a push. All right, the job has finished. We can see run ID here. The job run kicked off and transferred without a hitch, but let's go verify real quick. Dive back in here. Oh, the files are gone as expected. And let's double check our bucket in the cloud. And our files are there. Beautiful. That is a summary of data stores and transfer jobs. Use these anytime you need to shuttle data between your cloud and your edge and ensure users have lightning speed access to the data that they need to work with the moment they need to work with it. Bear in mind, you can set up schedules. That's one of the other powerful features of Edge. And so if you know what data sets your editors, for instance, will need to work with in their workday, you can set up schedules to ensure that whatever data landed at the hub that they now need to work with transfers down to the edge, say overnight when nobody's in the office. And once your editors arrive on site or log in and connect to the Edge box from their remote, all of the data that they need to work with is sitting there at the edge, ready to go. And that should do it. Next up, we'll take a look at the transparent cache feature. We'll explain how that differs from the transfer jobs feature we just reviewed, and how, when, and why you'd want to use it. All right, now let's take a closer look at the transparent cache feature, which you use when you are working with less predictable access patterns. Take a look at the data flow shown on screen. When users first access data through the transparent cache that hasn't yet landed on Edge, it will come over the WAN at network speed. Any predictable datasets that we know will be worked on were fetched and staged at the Edge via the cache warming schedule shown here in pink. Any data that has landed on the Edge is shown in green and is being served locally with the underlying storage appliance's performance guarantees. As the cache fills up, the LRU and idle TTL policies will work to free up space to make way for incoming data from the hub. The nice thing about this dynamic and this flow is that it largely keeps the administrator uninvolved. Essentially, all they have to do is set up the cache one time for editors and have confidence in its self-management based on those configured policies to rotate data out on the schedule necessary to keep the editors getting the data they need when they demand it. But let's actually set one of those up now. Follow me into the transparent cache demo now. Let's go into a live demonstration of setting up a transparent cache in Edge and using it to access a project file in Adobe Premiere. As a reminder, you would set up your users to work their data backed by transparent cache when you and/or they are unsure of exactly which data at the hub will need to be accessed ahead of time, and on-demand fetching is the most sensible solution for the given workflow. For this demonstration, you can see that I've actually remoted into one of our edit workstations in our lab. You'll see me both manage Atlas and Edge from the browser in this workstation, and then use Adobe Premiere to access our data in the hub and fetch it down to our Edge location for faster, repeated access. We will have a handful of configuration tasks we need to complete in order to set up the transparent cache first, and then we'll be able to demonstrate that on-demand live fetching workflow. To set some context for where we're at in the demo, I've already set up a file system over on my Atlas NAS, and that is going to be seen here. I've set up TC demo. This is going to be the location used for our transparent cache. We can take a quick look into the contents here just to demonstrate that as of now, we have no files here, no data has landed in the cache from our Cloud Hub just yet. It's an empty directory. So with this having already been set up, what we'll do is go into Edge and we'll establish a connection to that as our transparent cache data store. So I'll go ahead and click the create button in the top right here and give it a name. We'll call this our syscache. I'm going to set the type to cache. And you'll notice here that it will automatically lock us to the Edge data store role, as only edges can serve as the transparent cache. Last, we will hit the Browse button to navigate to the TC demo file system I dedicated to the cache in Atlas. That was in this path here. And there it is. Let's select it and let's configure the data store. Okay, and we can see it here showing up in the list of our data stores. It's marked here as the cache type with the Edge role. Let's go over into our transfer job menu and create our transfer job for the transparent cache. All right, we'll give this a name as well, TC Demo 11. I'll go ahead and make sure that I've selected the transparent cache movement type. This is what directs Edge to actually create a virtual file system mount that allows the user to browse the hub namespace before any data is actually transferred to the Edge. Our source data store is going to be this min.io instance I've set up to serve as our S3 object store Cloud Hub. And then you'll notice here too that the destination data store was immediately locked to our syscache that we just set up, as this transfer job and that data store are explicitly paired. Our advanced options menu also covers a few extra features. You can set a maximum cache capacity as the upper limit it may occupy in the file system that you have set up for it. As the cache approaches that maximum capacity, data gets rotated off according to a least recently used policy. You can also set a time to live policy where files that haven't been accessed after a set limit also rotate out of the cache and clear up space. Finally, there's the cache warming scheduler. I'll click the enable button. If enabled, it lets you browse the hub directory and target specific files you know will be worked on and that you want to have staged on the cache ahead of time. The warming schedule can automatically transfer those targeted files on a schedule and ensure that your workers have access to the data they need instantly. Between these three advanced options, it's extremely helpful in automatically managing the cache, enabling the data flow based on user access or LRU and TTL policies. For this demo, I am going to leave warming disabled, but I'll keep the capacity and TTL at their default values, and let's create the job. Okay, we see it here showing up in the list. This is establishing the connection between our Cloud Hub and our syscache location on the Edge box here. Now we can see that reported. I want to just click into it and show us the details page 2, and particularly take note of the mount path that OpenDrives Edge has generated. This is where we will run into Atlas next and create a share using that mount point. Let's copy this just for safekeeping, and let's go over into Atlas to set up our share. Go into our SMB menu and click into our machine and create a share. Let's give it a name for consistency, TC demo 11. And here we have the file path selector. This is where we're going to paste that mount point that Edge created for us in. Be sure to click the verify button to ensure that your file path is valid and that nothing went awry in the creation. We're going to leave all of the other settings at default, and we're going to save it to create the share. And voila, we can see it here. And there we go. Now that that's there, let's go ahead and mount that share to our system. So we will add a network drive. I'll go ahead and add in my system information and the share name, which was TC demo 11. Give it my credentials. And there we have it mapped. So now that this is mounted, what we're seeing here in the File Explorer is that virtual file system that the transfer engine creates. This gives us our view into all the data that sits at the hub. And take a good look here for a second, and I'll just jump over into our min.io tab to show that indeed same data here being represented as we see in the File Explorer. But this is where things get cool. Let's go into Adobe Premiere and open this project file up. Now, a quick reminder about how the transparent cache will work here. If the file or files have not yet been pulled down and are not yet living locally on the Edge box, then the first access attempt will be over WAN speeds, as Edge pulls that down from the hub to its location. Once that's done, however, the file can then be accessed from Edge and served with the underlying storage appliance's performance guarantees. In our case, that underlying storage is Atlas, which provides a massive performance boost from the Atlas performance engine, serving high fidelity data across multiple streams at once. Okay, but let's go back into Adobe and get this opened up. So open project, and we're gonna go look in the TC demo, and I'm gonna go digging for my Adobe project folder or file, excuse me, and there it is. Let's open this up. And so here as this, oh, let's keep going. As this goes to open this, we have that file transferring down from our hub location down to the edge, and we'll give it a minute here to do that transfer, allow Adobe to open up the file, and we'll be good to go. Once that file has landed and I work with it, anytime I go to reopen it again, so long as it hasn't been rotated out according to the TTL or the cache capacity policies, if it hasn't been rotated out, then I'm going to continue accessing it here from the local location, getting that awesome Atlas speed performance, serving up the file. I think we're about to get it. Here we go. We are in. Let's expand this a bit. Now that it's here, I can start working in Premiere to do whatever I need. I can start scrubbing through, seeing the footage at different places, and doing whatever work I need to. Once I've finished working a file and I've closed it out, my changes will automatically be pushed up to the hub, which is our single source of truth. I can move around here in Premiere freely, smooth as butter. But let's go pop over into Atlas really quick and double check that these files are indeed being served from our edge location now instead of directly over a WAN connection from our S3 bucket. Let's go explore our file system. Reminder, it's the TC demo file system. We can see some space has now been occupied. Let's go exploring. Here we've got our VFS, that's our virtual file system. And we can see some data has landed. And this is representative of just the data that I needed to access to do what I was doing in the project. And there you have it. Our files are here on the edge. They're being served locally. And that should wrap the demonstration for the transparent cache feature on Edge. Use it when you have less predictable access patterns for your data at the hub, allowing on-demand transfers based on user behavior. Transparent cache can automatically self-manage its capacity and rotate things out depending on what settings you've configured. All right, that was fun. Let's sum it up and drive this point home ad nauseum one final time. If you can write down what needs to move and when, use a transfer job. If you don't know exactly what data your users will need and access might be random, use a transparent cache. It's also worth noting here at the conclusion that if you have multiple edge sites in play, right now is the time of this recording, the transparent job configuration is best suited for multiple edge sites. Right now, transparent cache is only good to work with one single site, but in the future, we have support coming for multi-site coordination. That's it. OpenDrives Edge helps your data move between sites, centralizing data sets your users need while reducing egress costs, reducing data sprawl, and helping users access and work with the data they need as soon as they need it.